Okay, so we're doing another one on G-codes. So this is a modified version of the G-codes for the yellow parts. So within the P51 Mustang, there's a series of G-codes. Of course, you're still going to get um, your templates, or should you call them tessellated. These are the STL files which you then compile, if you like, into G-codes using Cura, which we've been looking at earlier on. But what if you wanted just to take the G-codes and edit the actual factory-based G-codes instead? So these are G-code basic, and you can edit them. So what I've done is I've taken the standard yellow parts, which include the aileron, the elevator, the tail section, etc. All of the tail parts effectively, including the control surfaces, and I've modified them slightly. So some of the settings within the G-code, this M140 and S70, this is the bed temperature, alright, and I've made sure these are set to 70, but what I don't want is I don't want the head temperature to be 230. That's just too hot for my filament. So I'm going to set that to 200. So both the 104 and the 109 settings, which are both related to the initial and the main, I'm going to drop these down to 200. All right, and these are the core ones that it loads up during the start. Anything with a semicolon in front of it is a comment. Alright, so these are just comments, and this is the actual original G-code that was created by Simplify 3D. Alright, now there's various interesting bits to read through here, and it's a good idea to have a read through it. Things like layer height, top and top solid layers, bottom solid layers, etc., etc. But you can kind of get the gist of some of these settings and what they relate to, and it's well worth having a good read through some of this. There's some quite interesting ones here as well, like what sound it plays at the end of the print run, and they're all, you can see some of those comment at the top and some come down the bottom. Here it is: celebration song, random song. So I made sure I've set my head temperature 200, my build plate at 70, which because I'm going to have multiple parts on here. And the other one that's important is this one here, which is to do with the extrusion and the retract rate. Now by default this is set to about 0.7, so look for G1E and then replace the values throughout the entire, and there'll be probably a couple of thousand of them. Replace the values for this G1E and replace them to the values that are better for your Bowden based system. And this is mentioned in that video from the CNC kitchen. It's mentioned right at the beginning. I think somewhere around, because he talks about different ways of editing the files. So somewhere here he starts to talk about the G-codes. All right, and he says basically go and have a look for the standard G-code settings, typically G1E-0800 for example, so that's 0.8 effectively, and then F1800. And he says go and have a search for these and then replace all of them. So that's what I've done inside of my modified version. I've gone and searched for these values, G1E, and then I've gone and replaced these with 4.5. So my Bowden system seems to like it around 4.5, and I've replaced these throughout the G-code. Again, there's settings for the skirt and various other settings under here, but because I can alter both the bed temperature and the head temperature. I can search for the flow rate, search for the retract rate, because I can modify the G-code directly. I don't have to mess around with the settings in Cura. I can just take the factory settings and then tweak them to work with the Anycubic i3 Mega S. And that's the beauty of using G-codes to get the results. So this is all of the G-code required for all of those parts, and various settings towards the end. You can also open these inside of Cura. So you can come down to here, just providing you've associated G-code with Cura, which is an option when you're installing Cura, to choose file associations, and one of those is, do you want to associate G-codes with it? Now mostly you'd probably use G-codes in Mesh Mixer or some other tool if you wanted to do some remedial work, and later video I'll start looking at Mesh Mixer because I'm intrigued to know how it can be used for patching, if you like, where meshes aren't quite working well, and adding additional layers and saying doing repairs to some of the STL files. So you can load up Cura with the G-codes, and then you can the G-code file, and then you can examine. You can't edit it in Cura, but what you can do, just wait for these to load, is you can have a look at the layout and have a look, zoom into the actual file to see what's at the objects rather, and see what they look like, and then you can compare that with the G-code itself. So you can having both the physical view of the actual G-code, and then you can go into the G-code itself and start looking at the actual elements within the G-code itself. So typically what I do is I would hold the shift key down in Cura, just move this view up a little bit. I then use my right mouse to rotate, right mouse and drag to the right, and then use the thumb wheel effectively. If you've got a middle wheel, you can then zoom in. So I'm going to hold the shift key again. So this has got all of the parts, including the wing tips, the engine mounts, everything's in here. But what I'm intrigued to know is, does it have a top and bottom layer? Yes, it does. And what these control horns look like. And I was comparing the G-codes with the actual STL files after I'd sliced it with the Cura settings, because I wanted to see if those control horns were slightly different thickness, because remember these are being produced in Simplify 3D, and what 3D Labs have been doing is they've been modifying the G-code, the outputs, using Simplify 3D to fix blemishes within the structure of the skin, for example, and to sort out any structural integrity of areas like this control horn. And I'd noticed there was a slight difference between the output of the STL file when it's sliced compared to their G-codes, their original G-codes. And I wanted to find out, what the key differences were. So this is the benefit of me taking this G-code and then editing the G-code to, for the particular settings for my printer, like the head temperature, the bed temperature, and so forth. But then benefiting from the work that's been done in Simplify 3D. Now, Simplify 3D obviously is a good product, but it's $149. And to be honest, do you really need it, considering Cura can do the bulk of it? And with a couple of free tools, including Mesh Mixer, you can pretty much fix the problems that are hidden within the STL files. So I kind of be investigating that a little bit further, because I don't see why I should be paying for something, especially when there's a lot of free software out there, a lot of open source stuff out there. So if I just, again, I'll just navigate around here. Oops, let's just bring that down to about here. It's a bit jumpy because it's got a lot of objects in it, but I can see 1, 2, 3, 4, 5 layers, plus this other layer in here, look, that's been added by the looks of it. When I slice this in Cura as an STL file, I don't see this layer, and I've got 4 layers in here rather than 5. This is a skirt that's bonded to the side, or a slight brim, because these parts are quite tall, so it's giving it extra adhesion. But 1, 2, 3, 4, 5, definitely a difference, and this layer here is definitely different because I've had a good look at this inside. Now, it's not a big deal that you've got an extra layer here. You can kind of compensate for it by adding a, you know, up to 3 or 4 millimeters in the base layer in here, so that this layer bonds into the base of this control surface and it gives it the integral strength. So you may find you have a slightly thinner control horn, but the strength is quite good, and you won't need a big fat control wire. You can use quite a thin one, thin piano wire, and use the small hole in there, and it's adequate. You just need to test the strength and integrity of it after it's printed to see if it's actually good enough for the job. So some of this is based on what you see before you print, and then after you've printed, to actually just measure this, if you like, the tensile strength of the material, and play around with the layers after you've, you know, had a good look at it. So some of these things, as I say, these are more advanced, but as you get more and more into this 3D printing, you begin to realize how much work goes into generating this from an engineering point of view. Alright guys, that's it. Thanks for listening.